Hi students, today we are going to see the topic coordination compounds and the nomenclature of it, and at the end of this video you are going to learn what are coordination compounds, what is the difference between a double salt and a coordination compounds, rules to follow in naming the coordination compounds, and how to name the coordination compounds finally. So, what is meant by these coordination compounds? So, which metals form coordination complexes or complex compounds? So, generally transition metals form coordination complexes. So, transition metals binds with the ligands and form transition metals, binds with ligands and form coordination compounds. The examples for these transition metals are magnesium, iron. You know that the transition metals, see for example, the transition metals are this group. So transition metals are the metals which are present between S block and the P block elements, and these are the transition metals. So transition metals form coordination compounds. The examples are well-known examples. Chlorophyll and hemoglobin are the examples for this particular coordination compounds. So coming to the applications, these coordination compounds find many applications in electroplating, textile industry and medicinal chemistry. Why we should read these particular coordination compounds and why the transition metals are very important. So these are all the different fields which we come across by using coordination chemistry or coordination compounds. So mainly the therapeutic drugs, chemical sensors, coloring agents. So these are everything here they use coordination chemistry. So especially the colors of these paints, you see various colors of paints, and these colors are due to the coordination of transition metals with varieties of ligands. So if the transition metal reacts with varieties of ligands, then different colors will come. So similarly, hemoglobin and chlorophyll, they use these coordination compounds, and in these coordination compounds they also coordinates, or they are also applicable in the jewelry technology. Say for example, in rubies show red color, emeralds show green color. So why the color is shown by these particular stones? This is because of the coordination that is giving this particular color. So everything here, medicine, paints and in germs, everything it is related to coordination chemistry. That is why these particular coordination compounds are very important to study. So what is happening in this particular coordination compounds? So if you see here in coordination compounds, the main element is transition metal. So transition metal, so what is actually here, this particular transition metal, it acts as Lewis acid. So Lewis acid is nothing but electron pair receiver. So this particular transition metal, it reacts with, or it adds, or it binds with these particular ligands. So ligands acts as Lewis base, that is electron pair donor, and these two form the bond, and the bond that is formed here is coordinate covalent bond, or otherwise known as dative bond. So this is the coordinate covalent bond, that is the complex that is forming in this particular coordination compounds. So these are all the various terms involved in coordination compounds. So coordination entity, central atom, coordination number and coordination sphere. So you can see everything in detail by taking an example. See, you can see here the coordination compound in detail. So here in this particular coordination compound, so you can see here the central atom, that is transition element, and these are ligands. So whatever that is bounded to this central transition element, these ions we call it as ligands, and these thing which is in the square brackets, you call it as coordination sphere. And the number of ligands, we call it as coordination number. Okay, so now this total compound is called coordination compound. So the ions which are bounded to central metal ion, we call it as ligands. So ligands are nothing but ions or molecules that are bounded to central atom or ions. So based on the number of donor atoms it is having, the ligands are classified into monodentate if it is 1, bidentate if it is 2, and polydentate if it is 3. So now let us see the rules to follow in order to name the coordination compounds. So the first rule, while naming the coordination compounds in general, the cations are named first and the anions are named next. So what are cations? Cations are nothing but positive charge group. So here if you see the example like this, so now CONH3 taken 6 times, this is called a cation, and Cl3 is called anion. So in naming first, cations are named first and anions are named next. So here if you see here, cobalt is named first and then this chlorine is named second. So I will take this example also and explain to you. If you see here also, which is named first, this is the cation. Yes, this is the cation and this is the anion. So excuse me, first cation is named first and then chlorine. So you can see here also, so copper is cation and this group is anion. So copper is named first. So this is the first rule. So first cations are named first and then anions are named next. Okay, the second rule, in naming the ligand, there may be many ligands present. In naming the ligands should be named before the metal ion. Okay, this is the rule number 2. So that means here in this particular thing, so ammonia is the ligand, right? So ammonia is named before the metal is named. So here the metal is platinum. Ammonia is named before platinum, right? So here you can see the examples. So if you take this particular sphere, so ammonia is written first before the metal. So here also you take. So ligands are written first before the metal. Here also you can take. So ligands cyano, it is written before the metal. So likewise, so ligands are named before naming the metal in the complex, right? So rule number 3, in naming the anions, suppose say for example anions, in naming the anions, suffix should be written as O. In naming the anions, suffix should be written as O. Say for example cyanide, see here, so cyanide, it should end with O, cyano. So for neutral molecules there are many examples and you can see here in detail. So if these are the anions, so it is, if it is bromine, it is written as bromo. If it is fluorine, it is written as fluoro. So these are all anions. So you can observe here O ending, bromo, fluoro, hydroxo, cyano, like this. So every anion is ended with O, right? So in neutral ligands, in naming the neutral ligands, there are many names. There is no particular ending. So you can see here water, aqua, CO, carbonyl, nitrogen, dinitrogen, like this. There are many names for neutral ligands. So some more rules. So now If there are more than one or two ligands, if there are many ligands, then how to name the ligands? Then alphabetical order is followed in naming of ligands. So here if you see here the example, so water, aqua, A, chlorine, chloro, C, beginning C. So in naming these particular ligands, alphabetical order is followed. So water is named first, aqua, so tetra, aqua, dichloro. So chlorine next, aqua first. So that is how this name is written. So now next rule. If complex is positively charged, if complex is positively, say for example complex means this square, coordination sphere. So this is positively charged, then how to name that particular compound, and if it is negatively charged, how to name this particular compound. So if it is positively charged, then the metal is ended only as metal. Say for example this cobalt is ended as cobalt. If it is negative, if the coordination sphere is a anion, then it should end with, metal should end with 8. So platinum, that is why here we are writing platinate, it should end with 8. So these are some of the rules followed in naming the coordination compounds. So now here we can see the examples, some of the examples. So now based on these above rules, now let us try to understand some more in detail about the naming of this particular coordination compounds. So here you can observe these compounds, and here the complex is a cation. So here the major coordination sphere is a cation. So now here you can observe the name of the right, in writing you are writing cobalt, right, full name cobalt 3 chloride. Okay, so now suppose if it is a complex anion, see here we can observe aluminium, it's not written as aluminium but it's aluminate, 8 you can observe here, aluminate, zincate, ferrate, like this. So because here the complex is a cation, everywhere the metal is written as a metal, cobalt, zinc, cadmium, metal as it is. So that is why here, because this complex is an anion, you are adding the metal and ending it with 8, right? So now here are some organic compounds, examples of organic compounds. For organic compounds, bis, for 2 it is written as bis, and for if it is 3 it will be written as tris, right? So for bridging groups, so for bridging groups also there is a bit different nomenclature. So suppose take for example these bridging groups, if it is like this, so now here this is the bridging one, so you should write mu hydroxo, mu that is the position, mu hydroxo, bis means here 2, so bis pentamine chromium 3 chloride. So similarly for this structure it is written as, so 2 bridges, so here one bridge, here one bridge, so this is amido, we are writing mu amido, this mu hydroxo, this is hydroxo, octa means 8, so here 4 and here 4, so total how many amines? So 8, so 8 means octa amine. Dicobalt, so cobalts you can see 2 cobalts, so dicobalt, 3 oxidation number, so ion. That is how you need to write the names of the coordination complexes. So these are some of the examples. You practice the writing both names and then the formulas, and you practice many number of examples. Practice makes man perfect, so practice everything. And finally, thank you. Thanks for watching. Have a nice day.